This lecture is going to cover the concept of reaction yields in a chemical reaction. So when we think about reaction yield, this is really getting into running reactions in lab. And so far when we've thought about things, we've always considered the theoretical case where on paper you perform a chemical reaction and what can you get out of it. But in reality, things don't go perfect. And so when we talk about yield in chemistry, the yield of a reaction is the amount of material obtained from a given chemical reaction. So it's how much product did you get? What is the mass of product you got out? Now, that differs from what the theoretical yield is. And so far, we've really only calculated the theoretical yield. This is the amount of product that it's possible to produce under ideal circumstances. But we all know in lab, there's always errors. You might drop something, you might spill something, you might transfer things, and not everything gets transferred. So when we talk about the theoretical yield, that is what is theoretically possible to get, but the yield is what you experimentally actually get. And so we as chemists often talk about what's known as the percent yield, which is just the ratio. What the percent yield is then equal to what's the amount of stuff you actually collected in the lab divided by what's the mass of product you could get, assuming everything went perfectly and you could collect everything, right? And that ratio is the percent yield. So let's look at a couple examples to show you how this works. So in our first example, we're going to look at a reaction between a solution of sodium hypochlorite, which is bleach, prepared by mixing sodium hydroxide with 25 grams of chlorine gas. And the question is, what is the yield of the reaction if only 15.5 grams of sodium chloride are recovered? So where do we start? Well, the way we're going to start all of these, as always, is with a balanced chemical equation. So if we tease through that word problem above, we could say the balanced chemical equation is really two sodium hydroxides react with Cl2 to produce NaOCl, that's the sodium hypochlorite, plus sodium chloride and water. Now, let's back up and go to the question again and reread it. And we're told that we're mixing sodium hydroxide with 25 grams of chlorine gas. So the first thing we should do is think about converting that chlorine gas into moles. So convert Cl2 grams into moles. And we do that using the molar mass. So we'll start with 25 grams of Cl2 divided by the molar mass to give us 0.353 moles of Cl2. Once we have the moles of Cl2, we can perform our stoichiometry and we can calculate how many moles of sodium chloride will that produce. Right? And what we're really doing is finding what is the theoretical yield. How much sodium chloride could we produce if everything went perfectly? And so to find that theoretical yield, we'll start off with the moles of Cl2. We're going to multiply that by our mole to mole ratio from the balanced chemical equation. So 1 mole of sodium chloride is produced for every 1 mole of Cl2 that reacts. And here I'm just going to tack on our next expression. We could stop here and we'd get the moles of sodium chloride. But in the end we want mass, so I'm just going to go ahead and multiply by the molar mass of sodium hydroxide. Multiply that out and we find 20.7 grams of sodium chloride. Now, what does that tell us? That tells us if 25 grams of chlorine gas react, the theoretical yield is 20.7 grams of sodium chloride. But in the problem, we're told we only actually isolated 15.5 grams, right? So that 20.7 is the amount, if everything went perfect, that's the theoretical maximum amount we can get. The 15.5 is the actual yield. So now we can plug it into our percent yield equation and say the actual yield divided by theoretical times 100. And so that 15.5 from the problem divided by the 20.7 theoretical times 100 is equal to 74.9%. That is our percent yield for this chemical equation. Let's look at one more example. So let's consider the reaction shown for the production of diethyl ether. And we're told when this reaction is performed with 40 grams of ethanol, 28 grams of diethyl ether are produced. Calculate the percent yield of this reaction. So I encourage you now to pause the video, complete this calculation, and then see how you did. Okay, so hopefully you recognize the starting place for this is to start with the balanced chemical equation. And then we have to think about how are we going to get to the percent yield. But first let's balance that chemical equation. To do so, we actually need to put a 2 in front of the ethanol. So now we have our balanced chemical equation. And if you didn't do that, that's going to throw off your mole ratios. So then we can write down our formula for percent yield, which is equal to actual yield over theoretical. So the first thing we're going to now have to do is calculate what is the theoretical yield, right? If 40 grams of ethanol react, how many grams of diethyl ether can we make? So to calculate the theoretical yield, start with what we're given. We're given 40 grams of ethanol. We're going to divide by the molar mass. That would give us moles of ethanol. Multiply by a mole-to-mole ratio, 1 mole of diethyl ether divided by 2 moles of ethanol. That comes from the balanced chemical equation. Then we can convert moles of diethyl ether into grams by multiplying by the molar mass. Plugging it all into your calculator, we get 32.2 grams of diethyl ether. So that is the theoretical yield, the maximum amount of diethyl ether we can make. In the problem, we are told we produced 28 grams. So now we can take our ratio to find the percent yield. 28 over 32.2 times 100, and we see that the percent yield is 87%. Thank you.